Hi, my name is Deepa Bhuvanagiri, and in this lecture, we are going to be covering data cleaning in R. So data cleaning is a very important step in the data science pipeline, and it is a lot of times referred to as the most time-consuming step. During data cleaning, our goal is to ensure that our data is correct, ready, and clean for proper analysis. During this step, a very common saying that people bring up is garbage in equals garbage out. And this is the idea that models built on poor or not clean data tends to give us poor or inaccurate results. So the purpose of this demo is to look into the basics of data cleaning and common functionality in R. And more specifically, we're going to be exploring the package Tidyverse, which comes with a lot of cool functions that we can use to clean and manipulate our data. Before we go any further, I just want to quickly refresh on what functions and packages are in coding. So a function is a way to group a set of code to run when called. And an analogy I like to think about to help understand how functions work better is a donut factory. More specifically, we have a donut factory and we're trying to make donuts at a large scale. So where we might start is to first get the ingredients to make the donuts. Then we would input these ingredients into the factory where the magic happens in terms of baking and making those donuts. And then the factory is able to output the donuts for the consumers to consume. So if we were to take this analogy and tie it back to coding, let's say we are trying to build a function called mean, which calculates the average of any set of numbers that we give it. So what this might look like is something like this, where we give it an input of a set of numbers, and then the mean function, which is similar to the factory, is where the magic happens in terms of calculating the average of the numbers that we gave it, and then it outputs what that average would be. Now, this can become very useful when we're trying to calculate the mean for lots of different groups of numbers. So let's say we have lots of different demographics that we want to find the averages of. We can then feed in each of those groups of numbers from those demographic groups into the mean function, and it will output the corresponding averages for each group. So this is just a really nice way to make our code more streamlined and more efficient. So in addition to functions, we have something called packages. And we can think of a package as, I know previously we just talked about how we might use a mean function. So now let's say we have a median function and a mode function. What we can do is we can group them all together, and this can be considered a package, and we can call this package stat summaries. Now, when we start to code, we can actually import this package, stat summaries, and we will gain access to the mean, median, and mode functions to use in our code when needed. So like I said previously, the package that we are going to be looking into for data cleaning is Tidyverse. And Tidyverse comes with a lot of cool functions that we can use to clean and manipulate our data. And these are the list of some of them that we are going to be covering in this demo today. And then in addition to this, we are also going to be looking into the pipe operator, which is a way to run functions one after the other, and it helps make our code more streamlined and easier to read. One last thing I want to cover before we get into the coding part of this lecture is just a refresher on what a data frame is. A data frame is a way for us to organize tabular data in code. It's super commonly used in data science. And a typical file with the extension .csv is something that you would probably use a data frame for when inputting your CSV file into your code. Down below is a screenshot of the data frame we're going to be using in this demo. And I just wanted to highlight how you can notice the structure of it, where it has columns or features for each of the rows in this table, and each row represents a data sample. So now moving into the demo, the first thing that we would do is we would import all of the packages that we would like to use for whatever coding purpose we have. So in this case, it would be for data cleaning. And I also have commented out code above. And when I say commented out, that just means that the computer knows not to run it because I put a pound sign in front. So for you to run it, you just need to remove this pound symbol. And you may want to run this if you get an error saying that it does not recognize Tidyverse. And so that probably just means that you need to install that package. And this code here does that for you. So after we've installed our packages, the next thing that we would need to do is import our data. And we can do this using the read.csv function. And our data is located in the file called ufos.csv. And so we're able to read in this data into the variable UFO_DF, which stands for data frame. So the data frame or the data set that we are going to be looking at for this demo involves UFO sightings around the world. So each row represents a UFO sighting, so somebody who had seen a UFO, and then all the columns represent attributes that pertain to that sighting. So the city it was sighted in, the state, country, the shape of the UFO, how long that UFO was in the sky for, the date that the UFO was seen, and then the geographic coordinates at which that UFO was seen at. After we have inputted our data or loaded our data into our code, the next thing that we would like to do is just to get an idea of the structure. And how we might do this is with a couple different functions. The first one being head, which allows us to just see the first 5 rows of our data frame. So you can see here we have our head function defined. We have inputted our data frame variable, and then we have n equal to 5, saying that we just want to see the first 5 rows. And then this is the output down below. The next function that we can use is the tail function, which lets us see the last 5 rows of our data frame. And it is very similarly structured to the head function that we just went over. And you can see again down below, we are looking at the last 5 rows of our data frame. Next, we can look at the dim function, which stands for dimensions. And this shows us the rows, how many rows and how many columns are in our data frame. So we can see here we have around 88,800 rows or UFO sightings, and then we have 8 attributes or columns to go with it. Lastly, we have a summary function, which can print out summary statistics for each of the columns in our data frame. So again, we have our summary function defined, and we are inputting in our data frame. And down below, for each of the columns, we can see the summary statistics. And one thing to notice is the first couple of columns all contain character values. So you can't really calculate summary statistics on that. But if we look at the duration seconds column, we can start to see that it was able to calculate summary statistics for that column. So far we have read in our data and we've kind of got an idea of the structure of our data. The next step might involve reformatting our data so that it all has similar naming conventions. And so what I mean by that is we can see here we have a function called call names, which stands for column names. And if we input our data frame, it's able to print out all of the names of all of the columns stored in our data frame. And so one thing we might notice is one column has an underscore representing a space, and another column has a period representing a space. And so maybe something we might want to do is rename one of these columns so that they match each other. And let's say we just don't like periods to represent spaces, and we want to replace this period with an underscore so it matches the duration underscore seconds column. How we might do that is using the rename function. And so we can write the rename function, input our data frame, and then we can write down the name of the column we would like it to be, so to have an underscore instead of a period, and we would set that equal to the old name, so the old name / current name of the column. And so if we were to run this and then store it into the variable UFO_DataFrame_rename, and we print out the columns for that new variable, we can see that it was successfully able to rename the column date posted to have an underscore instead of a period. So this is pretty cool. Now we can see how to do it with piping. Now, when I refer to piping, I'm referring to this symbol right here, which is the % greater than % symbol. And what piping allows us to do is if you were to look back up at this code where we have the rename function and we have our data frame variable as the very first input, instead, with the piping operator, we're able to just pipe that variable into the first section. So we don't even have to write it. And so it's able to register that it wants us to apply this rename function on this data frame variable. And we want to output it to this new variable called temp1, which stands for temporary 1. And if we were then to print the column names of temporary 1, we can see that this code also was able to successfully rename the date posted column. And so you may be thinking, that's great, but why would we want to go through all this trouble to rename a column when this line can do it just as well? And we will go into that in just a minute as to why we might want to use the pipe operator instead of just having to use this single line function and store it into a variable. So right now, we have just renamed a column in our data frame, and we have stored that new clean data frame in this variable called temp1. And so now what we're going to do is we're going to see how we can apply the pipe operator to another function. And this function is going to be called mutate. So before we get into that, we're going to first check out the variable types that are being stored in each column of our data frame. And we can do that with the str function. So if we were to run this, we will see printed out all of our column names. We will see all of the column types, all of the types of variables stored in each column. So for example, the state column is storing character information, which just is the abbreviations for all of the states. We can see in duration seconds, it's storing integer information, so the seconds at which the UFOs were seen in the sky. And then date posted is also a character. Something that we might do, which we will see later on why it will be very helpful, is to actually convert this date posted column into a date variable instead of a character variable. And how we might do this is with both the postxct function and then the mutate function. So the mutate function lets us mutate or change a specific column. And the specific column we want to change is the date underscore posted column. And what we want to do in this column is we want to convert this character into a date variable. And so we can use this function here. And we're specifying we want the date posted column to be changed into a postxct variable, which is a date variable in R. And we also want to let it know how the date has been formatted. So there's a bunch of different ways to write dates. And in this specific case, the date was written as month, day, and then year. And so that's what this is showing. M is for month, D is for day, and then capital Y is for the year written with 4 numbers. Instead of just having 04, we have 2004. So that's what that is saying. And then we are storing it into another variable called temporary2 or temp2. And so then if we were to print out again the variable types and the columns, we can then see that the date posted changes from character to postxct, which is a date format. So we're able to use the mutate function to convert a column into a different variable type. So here is the cool part. We just did 2 different types of data cleaning. We renamed a column, and then we also changed the variable type of a column. And what we had to do was each time we cleaned up our data frame, we stored it into a new variable. So this is temp1. And then when we wanted to further clean it, we then had to use this new cleaned variable, clean it up some more, and then store it into yet another variable. So what pipe allows us to do is we can actually just stack these cleaning steps right on top of each other so that we can take our original data frame with all of our UFO information. We can say rename the column date posted, and then we want to mutate that date posted column so that it contains a date variable instead of a character variable. And then we can output that into a new variable called UFO DF cleaned. So in this way, I put the analogy of like you're putting on your socks, then your shoes, then you're tying your laces. In that same way, we're starting with a quote unquote dirty data frame with dirty data. And we are first putting on our socks. So we're renaming a column. And then after we rename the column, then we're going to change that column to have a date variable. So then we're putting on our shoes. And then we can then output that into a new variable with our cleaned data. And so then when we type in, when we use the str function again, we can see, voila, the date posted variable has been renamed and it has been converted into a date format. So we're very easily able to clean our data by just stacking them one on top of the other using the pipe operator, which makes it clean. And you can also very easily read what is being done at each step. So cool. The next function that we're going to look at is the filter function. What this function allows us to do is filter our data to select a specific subset of it. So let's say, for example, we're looking at UFOs and we're just really interested in cylinder UFOs. And so we just want to look at all of the sightings that had a cylinder shape. So how we might do this is we can take our cleaned data frame and then we can filter it where we select the shape column of our data frame and we want it to only equal the shape cylinder. And again, remember in coding, we want to have 2 equal signs instead of 1. And so when we run this down below, we can see within the shape column, all of the UFOs have the shape cylinder. And so then we can do further analysis on this subset. Another way we can filter is with numbers. So here, let's say we're just really interested in all the UFOs that were in the sky for longer than 1,000 seconds. Again, we take our data frame and we take the column duration underscore seconds and we set it greater than 1,000. So we want to get all of the UFOs that were in the sky for more than 1,000 seconds. And then if we look at our output down below, we can see that all of these entries are greater than 1,000. Next, we can also filter on an interval. So let's say we want to find all the UFOs that were in the sky for greater than 1,000 seconds, but less than 2,000 seconds. We can write it this way, where we have the and symbol saying that we want it to be, greater than 1,000, but less than 2,000. And we can again see if we look at the duration seconds column of our outputted data frame that it also meets this convention where they are meeting this criteria. And then lastly, this is where it was important to convert our date posted column into the date format, is we can filter by date as well. And so now, because it is in this postxct format, we can take this date posted column and we can use this function year, which comes from the LubriDate package that we imported at the very beginning of the coding part of this demo. And what this is saying is that within this date posted column, look at all the years. So look at all the years section and find me all of the years that are equal to 2004. And this is the output of that data frame or of that code. And so this is a question where we're very curious about all the UFOs that were seen in 2004, and we can do analysis on that subsection. This is how we might do that. The next function we will look at is summarize, which lets us take the data, group it in a specific way, and then outputs a data frame for us to use. So the first thing we could do is we can take our data frame and then use the summarize function to create a new column called mean underscore time, which will calculate the mean of how long all of the UFOs that were ever seen, how long they were in the sky for. And then we are able to get a data frame where we just have one column and that one entry is the average of all the UFOs that were seen in the sky. Another thing we can do with the summarize function is we can actually have multiple columns. So we can make it a little bit more interesting to look at, where in addition to the mean time that a UFO was seen in the sky, we can also find the minimum time a UFO was seen in the sky and the maximum time, store them in these 2 columns, and we can use a min and max function to find that information. And the resulting data frame we can see here, where the column represents each of the criteria we defined, so the average time, the minimum time, the maximum time, and then we have those corresponding entries as well. We can also start combining these different data cleaning and data manipulation functions together to get even cooler results. So let's say we're just very curious to see the average time a UFO with a cylinder shape was in the sky. How we might do this is we would first filter our data frame to get all of the UFOs that have a cylinder shape, which is what line 4 is doing. And then we can use the summarize function to calculate the average duration of all of those subsetted UFOs. And so down below, we can see we have our column of average or mean time, and then this is the average time all the cylinders all of the UFOs with a cylinder shape was seen in the sky. The next thing we can do is we can add new columns to our data frame, and we can do this using the mutate function, which we had seen previously. And so how we can do this is previously we saw how we could use the mutate function to change an already existing column. And so now we can see how to add one. So far we've had this column called duration underscore seconds. And this has just been printing how long the UFO was in the sky for in seconds, which as the UFO was in the sky for longer, it becomes hard to interpret. So you can see in this first row, this UFO is in the sky for 2,700 seconds, which I'm not sure how exactly to interpret that. So how we can fix this is we can add a new column with the mutate function. We can call this column duration_minutes. And then we can take our duration seconds column that we already have, divide it by 60 to convert the seconds into minutes. And then we have this round function, which allows us to round our answer to just 2 decimal places. So we don't have a bunch of decimal places in our answer. And this is all stored again in the duration minutes column. So then when we have our resulting data frame, you can see we have all of our old columns that we had already have. And then we have this additional one called duration minutes, where it has converted all of our seconds to minutes. So you can see this first line, we can now interpret 2,700 seconds as actually 45 minutes. So this is cool. Next, we can use the select function to just select the columns that we are interested in. So I'm going to go back real quick just to highlight. You can see we have 8 original columns and we added an additional one, so there's like 9 columns. But let's say we don't really need to see all of these columns. We only care about a couple of them. More specifically, let's say after we create a duration minutes column, we really just cared about how long the UFO was in the sky. So let's say we want to see, in terms of seconds and minutes, how long they were in the sky for. And then we're also just really curious about what state these UFOs were seen in. So we can use the select function to select just those 3 columns. And then for the result, you can see we just have those 3 columns being displayed. So it's just a more compact way of just viewing what we care to view. In addition to this, another way we can select is just selecting everything but a specific column. And we can do this by using the negative sign or the minus sign. And again, let's say we cared about all the columns present except for the city column. So we can just do select minus city. And down below, you can see that the city column was not printed or saved. So that's another way to select. The next function we are going to look at is group by, which can be paired with summarize to get some really cool results. How we can do this is, let's say we are caring about what the average time a specific type of UFO was in the sky for. So what this would mean is, like, if we had a cylinder UFO, if we had a circle UFO, we'd want to find the average times for each of those shapes. How we might do this is, first, we would want to use the group by function to group by each shape. And then we can use the summarize function to find the average duration in seconds and sort in the mean time column. And because we are pairing it with group by, it will calculate the average duration in seconds for each of those shapes. And so we can see that here, where our resulting data frame, we have a column called shapes, and it is listing all of the shapes, not all of them, but I guess the first couple of shapes for the UFOs. And then we have a mean time column, which is showing the average time each of those shapes was in the sky for. So for example, the shape chevron, if a UFO had a shape chevron, the average time it was in the sky for was 488 seconds. So this is really neat. But another way to help view this data more clearly is we can also have the arrange function added to it. And what this will allow us to do is, once we have calculated the average duration of those UFOs per shape, we can add in the arrange function for the mean time to arrange it from least to greatest. So now we can see the dome shape, a UFO with a dome shape on average was in the sky for 2 seconds, and this was the smallest average time out of all of the shapes of the UFOs. And then it increases incrementally. Yes. Another way we can arrange it is by pairing the arrange function with the DESC function, which stands for descending. And this is just a way to flip it so that we can see which shape was in the sky on average the longest, and then it starts decreasing from there. Another thing to note here is, if you notice a blank entry here, this is just stating that these sightings, they couldn't get a proper understanding of what the shape is, so they just left it blank. And the last function pairing that we are going to look at is the end function paired with summarize. And so how we can use this is to pretty much count entries within a group. So I think this would be best seen with an example. So let's say we grouped all the UFOs by shape and we wanted to know how many of each shape there was seen. So we do the group by function, and then within summarize, we can actually use this n function and set that calculation equal to the column total. And then we can use the arrange function to arrange it from greatest to least. And so what we're able to get from this is we can see that the shape light had the total, had the most sightings with a total of around 17,800. And then it starts decreasing from there. We can also add head to this list of functions. And this will allow us to specify how many of the entries we want to see. So at the very beginning, we stated that head could show us the first 5 entries, but if we change it to 10, we can now see the first 10 entries. And so again, just to re-highlight for the piping operator, you can see how we have a bunch of different cleaning functions or data manipulation functions that we have learned. And the piping operator just allows us to apply one after the other to keep building upon different things we want to see. And that is pretty much it for the cleaning demo. I've added some extra code here just to show you how you can use, once you've cleaned your data, how you can start visualizing it, but you get to learn more about visualization in another lecture. So this is just something that you can come back to reference on how you can feed in your clean data into visualization code. And this is just an example of like a map that you can create to show where all of the different UFO sightings were. So yeah, thank you so much for listening to my lecture.